In this video, we will explore how to construct a confidence interval for one population mean when the population standard deviation is unknown and how to interpret this interval correctly. Let's consider the following case, where a random sample of 50 is selected for the change in the price of the stock. And we need to construct a 95% confidence interval for the mean change in the stock prices. Now, to construct a confidence interval for one population mean, we will follow a step-by-step approach, that is, in the first step, we will define the parameter of interest and check for the necessary conditions for the sampling distribution. In the second step, we will select the appropriate confidence level. In the third step, we will calculate the sample statistics and perform the corresponding calculations, and in the fourth and final step, we will interpret the estimated confidence interval. A parameter is a number that describes the whole population of interest, and a sample statistic is the number that is obtained from the sample dataset. In this scenario, the mean change in the stock prices is used to describe the population of interest. This means the parameter of interest is the population mean change in the stock prices. Before constructing a confidence interval, we need to ensure that the following conditions or assumptions are satisfied. The first assumption states that one observation should not influence others to happen, that is, the observations should be independent of each other. Since the samples are collected through simple random sampling, we can assume that the observations are independent of each other. The second assumption states that the samples are drawn from a normally distributed population. Since the sample size is greater than 30, according to the central limit theorem, we can assume that the sampling distribution of the sample mean is approximately normal. The third assumption states that the sample size should be less than 10% of the population. This assumption is also satisfied because the population contains the data for 500 companies. And the dataset should contain no large outlier. In the second step, we will select the appropriate confidence level. At a given confidence level, for example, at a 95% level of confidence, a confidence interval estimates an interval that contains the parameter of interest 95% of the time. This means if we do the repeated sampling a large number of times and construct a confidence interval for each sample, then 95% of the intervals will contain the true value of the parameter. In this case, we are asked to construct a 95% confidence interval for the mean change in stock prices. This means the confidence level is 95%. Now, to compute the lower and upper limits of a 95% confidence interval, use the following formula, where x bar is the sample mean, s is the sample standard deviation, n is the sample size, alpha is the significance level, and T alpha by 2 and T1 minus alpha by 2 are the lower and upper critical T values respectively. To calculate the sample mean and the sample standard deviation for the change in the price of the stock, use the following formulas. To find the T critical value, using the T distribution table, select the row for the degrees of freedom of 49 and select the cell corresponding to the alpha value of 0.05 for two-tailed distribution. The T critical value is 2.0096. Now, insert these values in the confidence interval formula. The lower limit of the confidence interval is -0.1578 and the upper limit is 0.4058. The 95% confidence interval for the mean lies between -0.1578 and 0.4058. This means we are 95% confident that the population mean change in all S and P stock prices will lie between -0.1578 and 0.4058. Please comment if you have any questions relating to this topic.